So let's cover LDP, or Label Distribution Protocol, GR, Graceful Restart. So I'll be covering this session together with Yash. This is the agenda. I'll go through an overview, cover the use cases, the details and caveats, the configuration, best practices, how to troubleshoot it, and hand over to Yash for demo and to close off. So 10.10 adds support for LDP GR, Label Distribution Protocol, Graceful Restart for MPLS deployments. What is the benefit of this? It basically preserves data plane forwarding during a control plane restart. Okay. So you can see here, PE1 or LSR, they're all LSRs in this MPLS network. Okay. You can, with this, you can add support for both the GR helper as well as the GR restarting LSR. So this feature adds both functionalities. What happens is, if there's a control plane restart, LDP control plane restart on the P device here, your traffic forwarding is not impacted. So that's the benefit. Okay. It's supported on 8360. If on the PE, if there's a control plane restart on the PE, same thing, there's no impact to your MPLS layer 3 VPN traffic, even though it's dependent on LDP. Use cases. The first use case is due to routing daemon restart. So this can work on a standalone switch like H60, right? So if the routing daemon restarts, control plane restarts, there's no impact to data plane forwarding. But in future, if there's a modular switch that supports MPLS with flow management modules, and there's a management module failover, this GR functionality will also help prevent data plane impact as well. So not applicable in 10.10 because H360 is a fixed switch, but this feature will be applicable to modular switches in future. So these are the two use cases for LDP GR. Details. So this feature is enabled by default. It cannot be disabled. It's based on RFC 38478. It requires the LDP Neighbor to also support LDP GR. Okay. This is an example of what you see. If PE2 has a neighbor with another device, P3, for example, but P3 doesn't support it, it will show GR as no. But if the neighbor supports LDP GR, it will show GR as yes with the different timers. And it requires the GR flag to be set to 1 during their LDP session establishment. If you debug MPLS, you check the buffer, you see initialization, LDP, and then they'll start exchanging information. The GR flag and GRFT is present. So FT refers to the fault tolerant TLV. This has to be exchanged during their session establishment. If you look at the packet capture, you can see the flag set to 1 using LDP Graceful Restart between the two LSRs for the LDP initialization message. This is the process. If there's a failure, you can see if there's a routing daemon restart on the P device here, PE1 and PE2 will actually detect a service interruption. You see the session has ceased to be operational because the routing daemon has restarted. PE1 and PE2 will mark all label bindings on the P as stale, but they will continue to use these bindings for forwarding so that there's no impact to LDP traffic forwarding. And PE1 and PE2 will keep trying to re-establish the LDP session with P. But after some time, when the neighbor liveness and peer reconnect timer ends, they will delete the neighbor session and delete all stale label bindings when the countdown ends. So that's the process, right? This will help when there's a restart, a short interruption. But if it's really down for a long period of time, this LDP GR will not help. So caveats to be aware, GR timers across these protocols need to meet this condition. Right? OSPF has to be the lowest, LDP has to be the middle, BGP has to be the highest. What I mean by this is the current 10.10 default. OSPF GR timer is 120, LDP GR timer is 150, but the BGP GR timer is 120. So this will not work. We need to manually set the BGP GR timer to be higher than 150. So you modify it to 180. As a caveat, if you enable GR on all three protocols in an MPLS network. So the plan is the future for the BGP GR timer default value to be modified to 180, so that there's no need for this manual workaround. Configuration is enabled by default, no configuration required, cannot be disabled, but the timers can be modified if desired. So you go into MPLS, you go into the LDP level, GR timers, you see there are three. So what do these three mean? Forwarding holding time. That's the amount of time in seconds that the MPLS forwarding state should be preserved after the control plane restarts. So the default is 150. Max recovery, that's the amount of time in seconds that the stale bindings should be kept on the router after the session has been reestablished. Finally, we have the Neighbor lively. The amount of time that the router will wait for LDP session to be reestablished. If the router cannot reestablish within that time, all that stale bindings will be deleted. So that's what I mentioned earlier. If this times out, then all the bindings will be removed and the neighbor will stay down. So timers wise, they do not need to match on between LDP neighbors. There will be exchange between the neighbors, and basically a device, an LSR will pick the lower value and use them for the sessions during GR. Okay, so whatever you see here for the neighbor are the received values. On PE2, which pairs to P3, the neighbor, you can see the time, the forwarding holding time 300 here is being set. You put yes, GR seen, and peer reconnect time is 300 seconds. On PE2, leave it as default. You can see here, neighbor liveness time 120. So on P3, you see peer reconnect time is 120. So the peer reconnect time is basically the neighbor liveliness time configured on the peer device. And the peer recovery time is the forwarding holding time configured minus the time control plane has been up. Best practices, it's best to leave the timers to default unless there's a reason to modify. So changing a timer will restart LDP sessions and may impact traffic forwarding. But because LDP sessions are restarted, this is considered a GR event. If you modify a timer like this, they will actually tell you, may result in traffic loss. And you can see, because the LDP sessions are restarted, the GR status in progress will be shown. So you can see GR, restart in progress is true, restart status is in progress. Cool. So GR is kicking in. So once the forwarding holding time is over, GR status will be complete and it's no longer in progress. So Yash will do a demo later and show you that GR progress as well. So troubleshooting, have your topology diagram ready. Make sure you have all the details of the ports used, of all the LSRs, the PEs, the Ps, because you want to check, right? Make sure your MPLS network is working correctly. Make sure LDP neighbors support GR. Verify the neighbors actually peer with GR. And if you need to, enable those debugs to check further. If you want to verify during a control plane restart, we'll show you how as well. Make sure the correct software is loaded. Right? You need 10.10 for this functionality. Make sure your neighbor is peer with LDP GR. So if you do show MPLS LDP neighbor, the GR should show yes. If required, you can enable MPLS LDP debugs, check the log, make sure you see the GR flags set to 1. Make sure you disable debug after that. So if you want to verify your data plane forwarding, do a control plane restart, you can do that routing daemon restart for now. And in future, you can do a management module failover to verify this LDP GR works. Right? So Yash will show the commands to restart the routing daemon in his demo. So with that, I'll hand over to Yash. Stop sharing.
Thank you, Daryl. So let me go ahead and share. Hope you are able to see my remote desktop.
Yes.
Okay. So before we get into the CLIs of the MPLS, let's take a 1 minute to review the topology, what I'm going to show you. As you see on the screen, all this blue color dotted box is all about the LSR, as you heard from Daryl. As he clearly explained, LSRs are the ones, the label switching routers are the one which are going to provide the labels for your network, right? So whatever the network, customer network is coming in, that's your MPBGP, which is going to start from this interface. So for that VRF, there is a label which is called as service label, or VPN v4 label, will be given by the PE device, and rest other labels are for the swapping purpose. The LDP GR is enabled between the link. What does it mean? As Daryl explained, if you look at it, if you are running a 10.9 image, that means 10.09, where the LDP GR is not supported, the neighbor here on the P1, though you are running the 10.10, will show you as GR is no, where in case of 10.9, the GR will show you as yes. The reason being, 10.10 support the GR, the 10.9 will not support the GR because it is a point-to-point GR you are running. So if you look at this overall topology, let's understand and then do a few minutes of demo so that you will be clear on what we are going to see. Consider this is a high school, which is probably one of the Granite Bay High School on the left-hand side, and you're trying to communicate to another high school in the same district, maybe Hoot Creek High School. So the Granite Bay High School network is probably 101, and that's coming onto the VRF1 on the PE1. What is going to happen? Anything happens in between. As you know, AOS-CX is all about daemons, correct? The control plane, any daemon will definitely have, for one or the other reason, they will fail. Let's consider the routing daemon, as Daryl explained, will go through a kind of a restart. When the routing daemon go through a restart, the LDP should not get impacted. That's called the seamless. As he said, one is the MPLS LDP will stay up. The reason because that is staying up, the L3 VPN will stay up. Because the L3 VPN stays up, you will see your application traffic will not have any impact. The overall goal, what is the goal? The user who is in the Granite Bay High School, if he is on a Zoom call, you should be seamlessly able to communicate to the Wood Creek High School, though there is the daemon, routing daemon, which is going on a restart with the LDP GR enabled. Let's consider the P3 device. I'm going to have which is having both the side 10.10. You can look at it, all have the 10.10 images. Only P4 will have a 10.9 image. We'll see that one also. Let's consider on the P3, because both the side is LDP GR is enabled, and even this is also LDP GR enabled. If I go and do a LDP restart or the routing daemon restart, the LDP GR will not go down because end-to-end LDP GR is there. That means the user traffic from all the way from the Granite Bay High School is able to reach the Wood Creek High School. Hope that is clear to you guys. So let's see a little bit of this network, because I'm going to use this network during my demo. The Granite Bay High School network is 101, where in case of the Wood Creek High School network is 200. These are the customer routes which are coming in. So what we'll do first is we'll try to ping from the CE1 to the other end of the CE2. That's the first we'll take a look at it. That means we are able to send some reachability is there from all the way from the Granite Bay High School till the Hood Creek High School. Okay, let's get started. It's all about, as I told you, we are going to restart some of the control plane daemon and show you this demo. What happens with the 10.9 image, because there is no LDP GR, how it's going to impact. And also we'll go and see on 10.10 image, if we restart the routing daemon, how it's not going to have any impact and you will achieve a seamless communication. Okay, let's go through the remote desktop. Hope this screen is visible to you all. As I showed you, I have a 5 LSR topology, P1, and it connects to P4, P5, P3, and the PE2. This is your provider network, which we call, which is nothing but the LSR. The CE1 and CE2, as I explained, CE2, if I remember rightly, it is the Wood Creek High School, where in case of CE1 is your Grand Bay High School. So let us check first. Go here. Let us check the IP route command. Okay, there are so many. So what I'll do is I'll just see what is my local route first. Okay, so I can see there's a 21.1. This should be reachable from the other side. Let's ping this one and check is my MPBGP is perfectly working fine or not. Okay, I'm able to reach from all the way from the Wood Creek High School to the Grand Bay High School. There is no problem with this. So as we go and check, as I told you, AOS-CX is all about daemon. That's our overall architecture. So if you go and see the daemons, what is the way to check all the daemons? Start shell, sudo bash. So to check all the daemons, you have to execute a command, system tctl list -unit -files -- type service all. CTL list unit files type service -all. That's the mistake I did. So you should be able to see all the daemons which are running on the AOS-CX. This will show you all the daemons which are running all the services. We call it as running on the AOS-CX. So what we are going to do, one of the daemon will first restart. As you see below, there is a traffic going from all the way from the Wood Creek High School towards the Grand Bay High School, same vice versa. Both you can see here, I have the bidirectional traffic which is going through. So what we'll do, we'll first check the LDP GR. The way to configure the LDP GR already Daryl explained. If you are running the 10.9 image and if you upgrade the 10.10, it comes as free for you, the LDP GR, because that's how the benefit, because it adds a value to your networks, automatically it get enabled. To check that one, show MPLS LDP Neighbor. This is the good command. Let me go and reconnect. Here you will see, though I'm running a 10.10 image, you will see the graceful restart as no. The reason being the peer node, the P4, is running the 10.9 image where the LDP GR is not supported. Let me log into this because we need all of these devices. You can see here clearly P4 is running the 10.9 image, where in case of a P1 is running the 10.10 image. Because the peer P4 is not supporting the LDP GR, you see on the neighbor node as no. And let's go and check here. You should see MPLS LDP Neighbor. You should see both the side yes, though it is running the 10.9 image. The reason being the peer node supports it. So you can see the same thing here. P4 has been connected to two neighbor. One is that's towards the P1 and also towards the P5. So what we are going to do here, we'll restart the routing daemon. So we are on 10.9. That means we should see an impact, correct? That's expected. So the way to restart this one is systemctl, same command. How you see all the daemons which are running on the AOS-CX, same command, no change, but you are going to provide a restart. I'm going to do a restart of the HPE routing daemon. -service. So if you want to check this one, you know how to check this one. I'm restarting now. As you see here on the below screen, you should start seeing some amount of loss because we are restarting it on the 10.9 image that's expected. You can see here we are having a loss, right? So network is now impacted. There is no seamless communication on a Zoom call from a Grand Bay High School to the Wood Creek High School within case of a LDP GR not enabled. That means if it is a 10.9 image. What we will do is, we'll first check whether this is coming back. Looks like it's back, and we should start seeing the loss should recover and things should be fine. So what I'm going to do, I'm going to clear all the statistics for the demo purpose. Don't do it anything on the live network like this. Keep the statistics, which is going to be important. So let's wait for the 00. Okay, let me get out of this network and check whether all the LDP is back, and I'm able to see the traffic is now flowing back. That means it recovered. This is the 10.9 impact. Let's go to the 10.10. That is nothing but the P3. That means P5 and the P2 are running the 10.10. How do I check that one? As you see on the above, everywhere MPLS Graceful Restart is enabled. Let us check the peer node. The peer node is P5. Let's go and check this one. Show MPLS LDP Neighbor. So you can see here also it is enabled. This is towards the P4. Hence it is saying no, we don't want to worry about that link, because we are going to break the link between we are going to restart the daemon between P5, P3, and the P2. So we'll worry about that one. That means you can see here that is Graceful Restart S. And on P3, both the side it is S and S. And we'll check the P2 before we go and restart MPLS LDP Neighbor. You can see here it is perfectly fine. So what we will do, we'll get into P3, start shell. We'll repeat the same command. In this case, we should never see any drop, correct? So PS minus AEF, that means the Zoom call, which is running between the schools, should not have any impact. Grab HPE routing. I want to just grab it so that you guys see the service is running with a different PID, and we restart and we'll see a different PID. Okay, so I'm going to restart this one, the way to system, CTL, restart, and this is the daemon we are going to restart. Okay, let's do this. As I do this, you can see there is no drop. And also, as Daryl showed, we should also see a command show MPLS Graceful Restart, LDP Graceful Restart. That is in progress, which he was talking about the timer. That's what you will see here. You can clearly see the current Graceful Restart is started and the timer is 132, though it is 150 because I restarted and came to this window. It is 132 now. That means it has a capacity to hold the overall LDP session on your network for 150 seconds. That means it is holding the LDP session, means it is holding the L3 VPN session. That means Zoom call, the application which is using that L3 VPN session, the Zoom call, is not impacted for 150 seconds. What happens after 150 seconds? It will check, as I already Daryl told, it will check still the routing daemon. If it not appears, it will bring down the L3 session. Okay, you should see after this 91 second, another status which is going to be complete. You will not have any impact on your L3 VPN session as you see on the below screen. Let's wait for 91 seconds. And these are the as debug commands. If you want to check debug MPLS, there is a command. In case of your troubleshooting, that's very important, especially when during the network, debugging a customer network. Make sure you check the point-to-point links are properly enabled with LDP. How do I check that one? Before you do anything, the best ways to check is the L3 connectivity. Currently, we support OSPF. We don't have ISS or anything on our platforms. As you guys know, the best protocols, the standard protocol we are supporting, the OSPF. So check your OSPF sessions are up between the devices. That means whichever the LSR you're choosing, check that one because LDP is point-to-point. Here, in this case, the P3 is connected to the PE2, which is nothing but the edge LSR or the core, the P3 is a core LSR. The P2, which is near to the Wood Creek High School, is the edge LSR. So now if you see on the P3, so edge LSR is perfectly fine, OSPF is up, and also the another core, which is a P5, that is also up. In the customer network, it will never be of this topology, isn't it? So you will have more number of devices connected because of the redundancy purpose. Here, I've connected the cloud, though the core LSRs are only these devices, but in the customer network, you will have a duplicate of these all devices because it's a network. It has to provide some redundancy, ECMP. So you have to check those things are connected and your L3 is up. Then check on those links is the LDP is enabled. If LDP is enabled, things will you should see the MPLS LDP Neighbor coming up. And once you have the LDP Neighbor, you can check your MPLS LDP binding. That means all the neighbors have the right labels or not. So let's go back and check our LDP Graceful Restart, whether it is come to a complete. You can see here it has completed and we never saw any impact on the network, which is a Zoom call, which they are enjoying between the Wood Creek High School and the Grand Bay High School. So with this, let me go back to the presentation. On the resource wise, as already Darrell said, LDP GR depends on a standard RFC. We always go through the best part on our on AOS-CX is we always implement the standard protocols, right? We never deviate from the standard. So we go through the RFC 3478, as you see on the screen. And you can refer this RFC for the LDP GR timers. And as already Darrell covered most of this, I think this TOI is more enough for you. But if you want to deep dive into all the timer details, you can go through this RFC. With that, I'll stop here. Thank you, Darrell.